Today we are going to see how the speed of the induction motor can be controlled using VFD. There are a number of applications where we need to control the speed of the induction motor. For an example, take an automated industry of Kisan Jam. We take an example, we need to fill both sachets as well as containers on the same conveyor line. In such case, the conveyor belt has to be moved in two different speeds. One speed for sachet and another speed for container. We assume that container may be half liter or 1 liter. So for filling the containers, it will be taking more time compared to the sachet. In such cases, the container has to be rotated slowly for containers compared to the sachet. So for that application, we are implementing the speed control of induction motor using VFD. That is programmed using PLC. This is the VFD from Delta. We have programmed this PLC in such a way that the induction motor will be rotated in two different speeds. Now the induction motor will be started by pressing X0. Now the induction motor is rotated slowly. It means we are filling or we are set up this conveyor belt for filling the containers. When I operate another switch, the induction motor is rotated faster, so the conveyor belt moves faster carrying the sachets. Now I am switching over to containers. So the motor started rotating slowly. Now I will switch over to sachets. That's how the induction motor can be rotated in different speeds using VFD. At any time, we can turn the induction motor off and on using another set of control buttons. This we have turned on the motor. So this is the way we can control the speed of the induction motor. Now let us look into the circuit diagram. As I said, we have used two push buttons connected to X0 and X1 for turning on the VFD and off respectively. This can be achieved by using Y0, which is connected to relay 1. You know that by passing the control signal 24 volts to multipurpose input 1, the device can be rotated in one direction. And we have control of speed using two push buttons, that is SP1 and SP2, connected to X2 and X3 respectively. When we press X2, it will be operated at speed 50. It will be operated at 50 hertz. When I press X3, the motor will be operated at 20 hertz. That is 50 hertz for sachets and 20 hertz for filling the containers. This can be better understood with the help of ladder diagram. Before that, the Y1 is connected to input of second relay, and as we have seen in the previous videos, by switching the 24 volts between multipurpose input 3 and multipurpose input 4, we can control the speed of the induction motor connected to the VFD. Right? See, by using this relay, we are switching the connection 24 volts between 3 and 4, that is multipurpose input 3 and 4. When the relay is on, normally open gets connected and the relay will be operated, the motor will be operated at 20 hertz. When the relay is off, normally close will get the 24 volts connection. The induction motor will be operated at 50 hertz. This VFD we have configured to operate at 50 hertz when multipurpose input 3 gets the 24 volt signal, and this VFD is configured to operate the motor at 20 hertz when 24 volts is connected to multipurpose input 4. The switching between these two multipurpose inputs is achieved to the second relay. And we know that to rotate the motor in any of the direction, either this multipurpose input 1 and multipurpose input 2 are compulsory to be on. That is what this multipurpose input 1 is for rotating the motor in anti-clockwise direction, and this multipurpose input is for rotating the motor in clockwise direction. Since we are just controlling the speed of the motor, we have made use of the multipurpose input 1, that is we are rotating the motor in anti-clockwise direction. We are rotating the motor in anti-clockwise direction and controlling it to operate in two different speeds. That is, switching on and off of this VFD to rotate the motor is achieved through the first relay, whereas switching the motor between two different speeds is achieved through the second relay. So we have got a PLC program which is very simple. Two DOL starter circuits are sufficient enough. We know that whenever I press X0, Y0 turns on, which in turn passes 24 volts to the VFD, it is multipurpose input 1. So it is ready to operate in the motor. And whenever I press X1 switch, it will turn off the relay 1, which in turn stops the control signal 24 volts to the multipurpose input 1, which in turn turns off the motor connected to the induction, connected to the VFD. So whenever I turn on the VFD using X0, then the speed can be controlled by using X2 or X3. Whenever I operate at X2, the multipurpose 2 is connected to the 24 volts. It means the device will be operated at 50 hertz speed. You know that for sachet, the conveyor belt has to be moved faster. So X2 is operated, the motor will be operated at 20 hertz. So sorry, 50 hertz. Now, whenever I press X3, relay gets off. Now the multipurpose input 3 is connected to 24 volts. Now the relay, the motor will be operated at 20 hertz, where we fill the containers, right? So we have programmed in this way 50 hertz for filling the sachets and 20 hertz for filling the containers. Thus, by any time by pressing the X2 and X3, the speed can be changed. By pressing any time the X0 and X1, the VFD can be turned on and off.
These are the physical connections from the PLC. We are using 4 push buttons X0, X1, X2, X3. One is for starting the motor, X1 is for stopping the motor, X2 is for operating the induction motor at 20 hertz, X3 is operated to start the induction motor at 50 hertz. This is for container, this is for sachet. Output Y0 is connected to the relay 1, output Y1 is connected to relay 2. Now, the common of both the relays are from 24 volts that we can see here, and normally open from the relay 1 is connected to multipurpose input 1. We know that from the previous videos, this is very much necessary. That is, we need to connect 24 volts to the multipurpose input 1 to rotate the VFD in forward direction. As we can see here, relay 2 is used for speed control. The 24 volts is connected to common of this relay as well. Normally close is connected to multipurpose input 3. And normally open is connected to multipurpose input 4. That is, at any time, two inputs, that is MI1 and MI3 or MI4 will be on, turning the motor in one particular speed. Thank you.